Bismillahirrahmanirrahim. Assalamu alaikum dear students. I'm Arif and I welcome you all to the next session on the subject of system programming with Linux. The title of today's session is Designing, Coding and Managing Daemon Processes or Services. First of all, I will give a quick overview of daemon processes. Then we will see how we can write our own daemon programmatically. I will give an introduction to the famous system daemon, systemd, and then we will see how we can control the daemons using the system control utility. And finally, we will write down our own service or daemon. Before we start writing a daemon process, let us have a quick recap. Well, dear students, a daemon is a system process that provides services to the system administrator without human intervention, provides services to the operating system kernel, or it may communicate with other processes. It has following characteristics. It is long-lived, often created at system startup and runs until the system is shut down. It runs in the background and has no controlling terminal. The lack of a controlling terminal ensures that the kernel never automatically generates any terminal-related signal for a daemon. Some example daemons are shown over here. The cron D that executes command at a scheduled time. Secure shell daemon which permits login from remote hosts using secure communication protocol. HTTPD is a server daemon which serves web pages. And Zynet is a famous internet super server daemon, extended internet daemon, which listens for incoming network connections on specified TCP/IP ports and launches appropriate server programs to handle these connections. Let us move on to the terminal and see some daemon processes which are running right now. ps-ajx. A means show processes owned by others. X is to show processes that do not have a controlling terminal, and J is used to show job related information like session IDs and process group IDs and so on. Oops, there are a lot of processes, daemon processes which are running. Let me use head to see the first 10. Well, you can see these all are the daemon processes. These are the PIDs, process group IDs, session IDs, terminals. Over here you can see a question mark, that is there is no controlling terminal. This column shows you the state, and in this column you can see you are seeing a S over here, which means these daemons are waiting for an event, interruptible sleep. You can see a D over here, disk sleep. That means they are waiting for some IO event. You can see an R over here, that means running. And if you see a T, that means the process is stopped by a job control signal. And you may come across a Z, which means zombie. Other than the first character, you can see some additional characters over here. This S, small s, this shows that this is a session leader. This less than sign means this is a high priority process. You may come across a N over here, which means a low priority process, which is nice to others. If you see a plus over here, that means it is in the foreground process group. And if you see a L over here, that means it is multi-threaded, created using clone. Let me just grab the SSH daemon. Okay, so this is information about the SSH daemon. Let's see information about cron. This is the cron daemon. Note that the PPID of these two daemon is 1, which is the ID of init, and they have same PID, PGID and session ID, and no controlling terminal. Let us fall back to the slides. Now we have a fair idea about daemons. Let me tell you the steps that a programmer needs to follow to programmatically create a daemon process. Step 1 is the program needs to do a fork, after which the parent exits and the child continues. Over here you can see I have shown the code snippet. The program do a fork, the parent exits, and the child continues. In step 2, we need to close all the open file descriptors that the daemon may have inherited from its parent. That's the standard descriptor, that is a 0, 1, 2. You might have seen this code in some previous session as well. I'm using getRlimit function to get the maximum number of files that a process can open at any instant of time. This rlim_max contains the maximum entries in the PPFTT, and I'm calling close in this loop to close all those descriptors, less 0, 1, and 2. Well, this is another important step. We need that only a single instance of a daemon process should run. Even if you try to run a daemon process again, it should not run. That is, no multiple instances of a daemon process should be running in a system. For example, if multiple instances of cron start running, each would run a scheduled operation, which is not required. This is the code snippet which ensures that if an instance of a program is running, no other instance should run. I've used a simple logic. I have created a file f1.txt, opened it in read-write mode. Then I've used the fcontrol system call to achieve a lock on this, to achieve a write lock on this file. So whenever another instance of this program will run, this will fail, and it will give the message that this process is already running. So this code snippet will ensure that only one instance of a daemon process should run. Let's move on to the step 4. In step 4, we need to make the file descriptors 0, 1, and 2 of PPFTT point to the dev null file. And this is done to ensure that if the daemon calls library function that perform IO on these descriptors, those functions won't unexpectedly fail. And it can be achieved in a very simple fashion. We need to call open on div null, and then we need to call dup2 to get a duplicate descriptor of 1 and 2. So finally all 0, 1, and 2 will be pointing to the div null file. The next step, of course, demands that the daemon should run in the background. So there is no need to have any terminal attached to them. And to detach the terminal from a daemon, we use a set SID system call, which also makes the daemon process the process group leader or session leader. And then we need to call umask to set the file mode creation mask to 0. And this ensures that when the daemon creates files and directories, they have exactly the same access privileges as mentioned in the mode specified in the open or the create system call. Rather than setting the umask, we also need to set the current working directory to the root directory. And this is necessary because the daemon usually runs until system is shut down. And if the daemon's current working directory is on a file system other than the one containing /, then the file system can't be mounted. The seventh and the last step is the sig hub signal should be ignored. Okay, let us move on to the Linux terminal and see this code in action. Clear screen. Let me run my daemon.c. Rather, let me open it first in the Vim. Okay. So I have written a function create _ daemon, and the main function is calling create daemon function. And inside this function, I have coded all the 7 steps which I have discussed, and then the program enters in a while one loop. Okay, uh, so this is the first step, that is we are doing a fork and making the child process the child of system D, and this, in the second step I am closing all the file descriptors less 0, 1 and 2, and in the third step I'm using the logic of file locking to ensure that only a single instance of a daemon process should run. In the fourth step I'm ensuring that the standard descriptors should point to div null, and I'm making the daemon session leader, setting the umask and the present working directory to /, and finally I'm ignoring the signal. So after all these steps are performed in this function and we come back to this while loop, this process will have all the characteristics or attributes of a daemon process. Let us compile and run this program. gcc my daemon.c /a.out. Okay, so daemon has started running with the PID of 15192. Let me do ps-ajx and let me query only this 15192. Okay, that is great. So you see this a.out, which is our daemon process, is running. It is having the PID, PGID, and session ID of 15192, and the parent is of course 992. Excuse me. And the status is RS, and we know R means running and S means this is a session leader, and this 992 of course is the system daemon. Let me show you this as well. 992, you see this is lib system D process. Although this process is doing nothing, just sitting in a while loop, but it has all the attributes of a daemon process. Let me kill it. Let me kill 15192. Let me confirm. Well, there is no such process anymore. Let us fall back to the slides again. Okay, so let's talk about the system daemon now. System D. Well, dear students, the system D is a system and service manager for all Linux operating systems. When run as first process on boot with a PID of 1, it acts as init system that brings up and maintains user space services. Remember, this init and system D are both a soft link to actually the lib system D program. You can confirm this on a terminal. Well, the system daemon has replaced the old traditional system 5 init daemon as well as the short-lived upstart daemon since Ubuntu 15.04, Reel 7, CentOS 7, Debian 7 onward. The two key advantages of system D over system 5 init are event-driven. System D is event-driven, and secondly, it do a very fast booting as compared to the init daemon. Well, systemctl is actually a program that is used to introspect and control the state of the system D system and service manager. They both are very much related. If you want to introspect what system D is actually doing, you can use systemctl utility. The systemctl command uses unit files to describe services that should run along with other elements of the system configuration. A systemd unit file is basically a configuration file that describes how to manage a specific resource, and that resource can be a service, which is the topic of today's discussion. It can be a target, can be a socket, mount, auto mount, timer, and there are others as well. Let us move once again on the Linux terminal and make our hands dirty and use systemctl to control the system daemon, and let the system daemon to manage our services or daemon processes. Let me clear screen. Let me first check out where is systemd installed on our system, which systemd. If it is not installed, you can always use sudo apt-get install systemd. Let me do ls-l and let me see the long listing of this program, and you can see this is a soft link to actually lib systemd program. Let us find out the famous init program as well, which init. Let me do sudo which init. Okay, so sbin init, this is the path, and let me do ls-l sbin init, and once again you can see that this program is also a soft link to lib systemd program. Let's see the man page of systemd. Okay, so do read this man page when you have time. Systemd is a system and service manager for Linux operating systems. Let me do a man to systemd.unit to have some information about the systemd unit files. You can see there are a lot of types of unit files: .service, .socket, .device, .mount, and so on. And the location of these system unit files are @c systemd system, run systemd system, and lib systemd system. Let me show you these as well. Let me do ls @c systemd, and the path is @c systemd system directory, and you can see these are the unit files which are there in this directory. And of course, if you see lib systemd system, it has a lot more unit files over here. Anyway, let's fall back over here. Do read this man page when you have time. Let us now talk about different types of these unit files which I have touched upon over here. Let me clear screen. Let me use see the man page of systemctl as well before I show you those. It is used to introspect and control the state of the system daemon. -t is used to show different types of unit files. Okay, systemctl -t help. So these all are the system unit files. Remember this service unit file. They are used for managing daemon processes that can be started, restarted, stopped, enabled, disabled. And this socket unit file describes a network socket. Socket unit file always have an associated service unit file that will be started when some activity on that particular socket is seen. Well, this these target units actually group units together and represent state of the system at any one time. These targets are similar to the run levels in older systems. Well, you can see the man pages of these unit files. For example, man systemd.service. This is the information about the service unit configuration file. We'll fall back to this soon. We can see systemd.socket. This describes the socket unit file. You can see systemd.target. This shows you the target unit configuration file, and similarly you can see the rest as well. Since today our main concern is about writing our own services, so let us see what all we can do with some existing services using systemctl. Let us talk about the secure shell daemon. Let me first check the status of the secure shell daemon using systemctl status ssh. You can see that secure shell daemon is active and running, and you can see the PID of this process, and you can see the path as well. And let me stop this, stop ssh, and I think I need to be sudo for this. And let me check the status again. You can see it is stopped. Let me start it again. I need to be again sudo for this. Let me start it. Let me check the status. It's again running. So you can do a lot of things with services. For example, you can start, you can stop, you can reload a service. By reloading, I mean without restarting the service, just reload the configuration file. Similarly, you can enable the service. You can see over here it is disabled. Let me enable this. Sudo systemctl enabled, and the name is ssh. Okay, so you see what it has done. It has actually created a soft link of this to this, and if I do the status again, you can see it is enabled over here now. Before it was disabled. So what do we mean by enabling a service? Excuse me. Well, dear students, you can enable a service. You enable it if you want it to be started automatically on boot. And similarly, you can disable a service. If you disable a service, that means the service won't come up on boot. However, you can start a disabled service without enabling it. Other than enabling and disabling, you can do masking and unmasking a service. If you want to make a service completely unstartable automatically or manually, you can do so by masking that. And to undo that, you can do unmask. Okay, let me clear screen and fall back to the slides again. Okay, so how to manage services using systemd. Dear students, now you know how to check the status of a service. You know how to start, stop, enable, and disable it. The next task is use your favorite programming language to write a long-running program and turn it into a service using systemd. So there are 4 steps which are involved. You write a long-running program in whatever language you feel like. You write a unit file, appropriate service unit file to manage that program. You copy that program and that unit file to appropriate directory. And then you use systemctl to start, stop, enable, and disable that service. Okay, so dear students, you can write in any language of your choice. But let me use Python to write a very basic UDP echo server. I'm using Python because I can do that by writing just 4 or 5 lines of code. Let us move on to the terminal and see this. Which Python? Well, the Python is there. Remember, Python is an open source and it is available on all Unisys and all distribution of Linux, Mac, Windows, Android, iOS, Raspbian, a lot of platforms. It is normally used for rapid prototyping and proof of concept. And if it is not installed on your machine, you can do sudo apt-get install Python, which is the latest version. So let me check out what all versions are there. 2.7, 3.5, these are the 2 newer versions. Remember Python 3 onward is not backward compatible, so still people are using Python 2. Okay, so far so good. Let us see the code of the server program which we have written in Python. Let me do vim my ecoserver.py. So .py is the extension required for Python. So these are just few lines of code. First of all, I'm using the import statement. I'm importing the socket module, and you know, a module is in Python is actually a file containing variables, functions, and classes related to these tasks. Then I'm using this socket function of socket module, which is passed two arguments. The first is the socket family, AFINet, internet family. The second is the socket type, that is the sock dgram. I'm using UDP for this. Well, this function will return a file descriptor, which I'm receiving in sock fd. Then I'm calling the bind function on this descriptor, and I'm binding it to the local address 0.0.0.0, and the port is 54154. I need to give a tuple containing host IP and port number over here. Then I'm just printing that the eco server is listening on this, and then I'm entering in a infinite loop, and in this infinite loop this program will be blocked on a function call that is rec20from. And this rec20from is a blocking call actually, which returns a tuple containing the data received and the client address. The data will be received in this payload and the client address over here, and this argument is actually the buffer in which the data will be received. Excuse me. And then after doing that, I'm using the send to function, and I'm sending back that payload to that client address. So this is a very basic eco server. I hope the code is making sense to you all, even if you do not know or do not have much idea about how Python works. Okay, so let me run this program, Python my ecoserver.py, and you see this is saying that it is running on this. And let me fall back over here, clear screen, and let me use the netcat program. Let me do man first. Well, this netcat is a TCP/IP Swiss Army knife. It is a utility that reads and writes data across network connections using TCP/IP or UDP protocols. Let me use NC, and let me say -u means I want to use UDP. 127.0.0.1 is the IP, and 54154 is the port number. And let me say hello, and it echoes back hello. This is fun, and it echoes back okay. This is great, and this is great. And I press Ctrl C, and I'm back. Over here, the eco server is running. I run it again and say the old saying, learning is fun with Arif. Bye. Okay, so that is working. Let me close this server program as well. Okay, now we have written a program and it is working fine, but we want it to be running as a service and managed by systemd. So for that, we need to write a service unit file. Let us fall back to the slides. So the step one is over, that is, we have written a long-lived program, and the next task is to write a unit file. Well, dear students, all unit files are organized with sections, and a section is denoted by a pair of square brackets with the section name enclosed within. And if we talk about the service unit files, you normally see these three sections over there: unit section, service section, and the install section. The unit section is mostly the first section found in most of the files, Although section order does not matter, but mostly this is placed at the top. It defines metadata of the unit file and is used to configure the relationship of this unit with other units. And this service actually is applicable only for the service unit files. You can find socket, mount, auto mount section instead of the service section in other unit files. And finally, the install. This is often the last optional section and is used to define if this unit is enabled or disabled. Only units that can be enabled will have this section. Well, to get help about the service unit files, you can always use the man page, and to display the contents of any unit file, you can use this command, systemctl cat, and the name of that unit file. Okay, so let's write down our own service unit file for the program in Python that we have written, and let us name it myeco.service. Let us fall back to the Linux terminal, clear the screen, and let us first see the service unit file of SSH daemon. Systemctl cat ssh.service. You see, this is the service unit file having the unit section, the service section, and over here we have the install section as well. Okay, now we need to write a service file for our eco server. To save time, I have already written it, myeco.service. So this is the file that I have created in the present working directory. Under the unit section, the first directive is the description, which says a simple string, that is, this is a service written by Arif, and this after means this service will be enabled after which target, which run level. So I say network.target. As far as the start limit interval section is equal to 0, that means after how much time this service should be started. Well, the type of this service is simple. Other types can be forking, one-shot, dbus, notify. Let me show you the man page so that whenever you are stuck up, you can see this. systemd.service. Let me move down, and you can see all the information over here. This is the type. Okay, what else? We have remain after. There are a lot of directives that you can use. A lot of directives. So whenever you are stuck up, please do see the man page. Do see the man page. Let me fall back. Restart is equal to always. By default, actually, systemd does not restart your service if your program exits. So this directive will override that default behavior. Restart sec is equal to 1. Once again, by default, systemd attempts to restart after 100 milliseconds. We can specify a number of seconds to wait before attempting to restart this service. And this is a very important line, that is exec start. This exec start directive is basically given the command and the arguments that are executed when this service is started. So this is the command usr bin python, and these are the arguments to this command, that is, it needs to run the myecoserver.py file. And finally, we have the install, which again says that this service wants that multi-user.target. The system should be in this target, in this run level. And this is the alias of our service, myeco.service. This is optional. It is always better to give an alias to your service. So let me ls. So we have written this file, myecoserver.py, which is a long-lived program. You can write it in any language. And then the second task which I have done is I have written the service unit file for this. The third task is to copy our program file and the service unit file to appropriate directories. So let me do sudo cp myecoserver.py and let me copy it to usr local bin and this is where the service unit file will look for it. I have given this path in the service unit file. That is why I'm copying it over here. And now I need to copy the service unit file as well. cp myeco.service, and this needs to be copied to, remember, @c system d system, to this directory. Let's confirm @c system d system, and if I see this directory, you can see over here myeco.service. This is the service unit file over here. Okay, now we are done. Let us start the service and enjoy. Systemctl status myeco.service. You see the service of course not running, and this is the description which I am getting, myeco service by Arif. But it is loaded in this directory, it is disabled, inactive. Let me enable it, or rather let me start it first, and let me say start. And if I see the status again, you can see it is active and running. However, it is disabled, that is, it will not automatically restart on a reboot. So let me enable it as well, and for that as well I need to be sudo. Okay, so let me check the status, and you can see it is still disabled. Okay, failed to enable unit. So why it has failed? Let me check the status again. Systemctl status myeco.service. It is disabled. Let me enable it. Sudo systemctl enable. It says the file @c system already exists. This file is already there. So okay, fine. Actually, what happens on enabling a service is, if the service unit file is there in lib systemd system, a copy will be created over here, a link will be created in this directory, and if we already have the file copied over here, we don't need to enable it. Actually, I have intentionally not copied this service file in the lib systemd system because it is normally not recommended. Okay, so anyway, it is running right now. Let me use ps-ajx command, and let me query this process. What is the ID of this process? myeco.service, and the ID is 15592. Okay, so let me use ps-ajx now, and let me query only one process having the ID of 15592, and there you go. You see that this is now running as a service, because you see the PID, PGID and the session ID all are same. The parent of this daemon process is init or systemd, no controlling terminal. The UID is 0, and so on. Okay, so if this is running, let me do ncat netcat -u 127.0.0.1 54154, which is the port number, and learning Linux is fun. Oh great, I am really enjoying it. Don't know about you. That is great. Let us move back to the slides. So once again, step 1 was writing your own long-lived program. Step 2 was writing your service unit file. Step 3 was copying the program and the service unit file to appropriate directories. And step 4 was enjoy. using systemctl. Okay, so that is the end of the session. I hope you have a fairly good idea about daemon processes or services in Linux, and you know how the systemd manages all the services at the back end. You can always write down a long-lived program with an associated service unit file, and then can use the systemctl utility to start, stop, enable, disable, mask, and unmask that service. You can use systemctl to start, stop, or manage the operating system services as well as the services that you have written at your own. I hope today's session was informative for you all. If you have liked it, please subscribe to my YouTube channel and share it with your friends. Wish you all the best, happy learning, and Allah Hafiz.